Good afternoon, everyone. I am so excited to be here with you all today to learn and share more about the partnerships that NCDOT has fostered with universities across the state. I'll be serving as the moderator of our discussion this afternoon. Research and development plays a critical role at NCDOT, helping us to change the future of transportation. We have recognized the benefit of including external partners, such as universities, to increase our knowledge base and help us continue to innovate. NCDOT has a history of partnering with universities and community colleges to help solve transportation problems. We have long-standing partnerships with multiple historically black colleges and universities across the state to host fellowships and internships to create an early talent pipeline for our workforce. We also partner with universities to help us develop new solutions to problems we are facing. Today we have 4 panelists from universities across North Carolina, all of which have active research and development partnerships with NCDOT. Here with me today are Dr. Rachel Liu, professor at NCA&T, Dr. Abdimnasser Karwi, professor at Elizabeth City State University, Dr. Don Chen, professor at UNC Charlotte, Dr. John Hildreth, interim associate dean at Western Carolina University. Each of them are going to share a little bit more about the projects they currently have ongoing and the importance of these R&D partnerships. We'll get started with Dr. Liu from NCA&T.
Thanks, Kristen and Megan. Good afternoon, everyone. My name is Rachel Liu. As you can see from the slide, I am the Director of Transportation Institute and also endowed professor supply chain management at NCAT. Here I'd like to give you a general overview of a few highlights we are doing in Transportation Institute. First of all, you probably heard as a academia or university division, oftentimes you have the 3-leg stool. For us, that's research, education, and technology transfer. Those who are familiar with NCAT, you might have heard, or if not, here you know, the Transportation Institute has been established since 1970s. And the big part of our mission is to be an information or education center for national, regional, and local clearinghouse. Any information related to transportation, development, supply chain, you can come to us for information. And of course, we have various products, seminars, workshops, and various lectures, podcasts, and I will show later even our legendary legacy program about STI, Summer Transportation Institute. So this was a research. A big part of research, of course, is grants from public or private sectors. And another big branch will be UTC, basically University Transportation Centers. I will get aboard more details later. And another aspect or big element our student program or education program is scholarship. We actually facilitate quite a few scholarships for our students who are interested in transportation, supply chain, or anything related to this field. And then another big part of our mission is community outreach. We actually work with local communities, marginalized communities, and now with UTC, our focus actually shifts to rural communities. Here I just gave you a couple examples. This is one of the research grant I have actually for NCDOT. This is under the Bureau of Research. The whole focus of this project is modeling the effects of real noise propagation on pedestrians. Those you heard or know about real operations or real safety records. Since the 70s, 80s, the casualty associated with a railroad crossing actually goes down. However, one particular program or aspect of rail safety is trespassers. If you actually cross a railroad or walk along the tracks and get struck, when the rain comes. That number did not go down at all, actually constantly on the rise. We're wondering why. I'm sure here I see a lot of young faces. You're probably pretty big on social media, right? We don't know since when suddenly trending along the railroad tracks become trendy. You probably put on your Facebook, your Instagram. Look, we're walking along the railroad tracks, or we cross, we jump back and forth, which many people don't realize that's quite dangerous because the train has very high speed. Was not as noisy as you thought or as your grandfather told you. It's always noise. Now with technology, it's not so. So oftentimes you have huge sort of impact on the safety record. And of course, the movies, all the social media you watch doesn't help either. Oftentimes they are featured like very noisy, very big. So with all of those factors, the mission of this project will actually collect the data in the field. We're trying to model how the noise propagate if you are walking along the railroad track, if you cross the railroad, and especially if you wear a earbuds. How did you perceive? How did you receive the noise? Whether you can hear or not. After you see the train, can you really move out of it? Oftentimes you can. So this is a NCDOT grant I am currently managing. And here's another one we just completed for US DOT. This is called AMJP. Basically is a independent evaluation of AMJP program, which stands for Aviation Manufacturer Job Protection Program. This program is closely related to COVID, which actually was authorized during the height of COVID by the Congress. They allocated like $3 billion to give out to aviation-related, usually small business, like repair stations or small HVAC or repair shops, because as you know, when all of the airplanes are grounded, they don't need to be repaired. So those small businesses often has no work, and often small business cannot carry people without job a year, half year. So this program was created, and US DOT received the task, say your job is disseminate, of course, to the companies or people needed the most, but you have to follow whatever directions from the Congress. After working on the program for quite a few months, very intense, this division was actually created out of the US DOT Secretary's office. As you recall, everything was so new, so sort of never heard of the first time. They actually couldn't give out the $3 billion. After 3 rounds, they only disseminated about a quarter, 700 something million. So as you probably know, the secretary was pretty nervous. Like before we always complain we have no money. Now suddenly we got 3 billion. How can we not give out? Because when you from the government, from the Fed, when you give out the money, you're supposed to follow certain rules. You can't just like PPP is a bad example, right? So many bad actors actually getting money fraudulent way. So this is a part of DOT really trying to avoid that pitfall. So I was commissioned to do this evaluation. We actually interviewed quite a few stakeholders, people who applied, got the grant, who applied, did not get, or who did not apply, and then some of the association. We're trying to understand why. How did you get it if you applied? If you are rejected, why? And then what DOT did and to accomplish, or what part really made it difficult. So there's 3/4 of the grant left. In the end, we concluded the DOT staff actually did a pretty good job. It's really just very restrictive sort of the regulation. And the other thing is lack of information. By the time they have this money allocated, they really don't know who is aviation related small business, who is a qualified personnel. So basically from ground zero, they have to work through that. And in the end, it's like the maximum amount they can give out. And just actually 2 months ago, this went through the federal or the GAO inspection. They have a pretty positive remark. And this is another aspect I'm going to mention on the research side. Besides, the grant I manage or we work on, another big sector is UTC, University Transportation Center. Here, luckily, we actually, under TI, we have 2 centers we lead. One is called Tier 1, which is the smallest or the entry level. We received this about 5 years ago, so it's about to wrap up. And the new one just started, the regional center for rural connected communities. I'm pretty sure some of you have went to our testing track or rode the driverless cars. And if not, stop by the booth. Ali and his staff are here, sort of provide information. This center is directed by Ali and Miranda, so they are the co-director of the center. And the focus is rural communities and with big emphasis on autonomous vehicle. Aside from those 2 we lead, we also support quite a few UTCs. Some of emphasize security, others on supply chain management. Then another one is actually on traffic or network optimization. And this is where I mentioned earlier about our legacy program. It's called STI, which focus on high school kids. We often have them during the summer. The program actually started in the 1970s. We are the pioneer of this program. About 20 years later, after we started here at NCAT, US DOT, Federal Highway, actually said, we want to do a STI because we heard a lot of good things from this. So very much Federal Highway modeled after our sort of Summer Transportation Institute. Now you can apply. This is a grant program. Many universities around the country actually do Summer Transportation Institute. For us, we actually started after I got here about 3 years ago, and of course, right after COVID, or still toward tail end of COVID. We're alternating between like 4 weeks day program versus 2 weeks residential. And this year and last year we did residential. After we sort of streamlined the program, it developed a real strong reputation. Last year, I was joking with our attendees at our opening ceremony. Kristen was there. Our admission rate is actually more selective than Ivy League schools. If you look at Harvard MBA, the admission rate is 12%. Guess what our admission rate is? About 5%. We have 20 slots last year. We have 400 applicants. This year, it probably going to be run very similar. On that, not only once you develop the reputation, you get recognition from attendees or public sectors, again, great support from DOT, but also private sector. Just last month, actually, we received a grant from Honda Foundation. They said, we want to run this 100K. You can use whatever you wanted, but specifically for STI. So this is where we're really trying to get high school kids into transportation field. Doesn't matter you are planning, engineer, pavement, as long as you're interested in transportation, we're trying to show you what it feels like and what are the potential places, DOT, private sector, or variety of field. And community outreach, this is where I think, from DOT or your private sector, local communities, you probably see our interaction. Last year, we actually helped Greensboro to apply for Safe Street for All program. They got, after a couple rounds, we sort of talked to them and discussed how to put this package together. They got a $750,000 planning grant. And right now I have another project is called the Thriving Communities Program, which is by USDOT. We actually support a variety of communities around the country, total about 14 RT from North Carolina. Charlotte is actually one of the communities we support, basically trying to improve transportation and help them to go after funding. This is in a nutshell. I hope it's not too much more than 10 minutes. And this is, my contact information. If you want to know more or, on this continued conversation, feel free to reach out. Now I pass down to Corey.
Thank you very much for this opportunity. Good afternoon, everybody. My name is Abdelnasser Kahoui. I'm professor at Elizabeth City State University, and I'll be talking today about alternative transportation technologies, focusing on efficiency and sustainability. It's about integration of renewable energy technologies with modern transportation infrastructure. I mean, here is about powering, not just control or service related to transportation, it's powering the vehicles with renewable energy. As you all know, the NC transit system is diverse, but mostly relies on cars. But the use of personal cars is 25 to 30% of capacity, because the car is designed for 4 seats, but you see mostly one person, only one passenger, the driver, and therefore the cars and the associated infrastructure is just 25 to 30% efficient. On the other hand, public transportation is underutilized, at the same time is not fully satisfactory according to the average users. And because it's powered with hydrocarbon, it brings problems like the energy availability as well as the pollution problem. It accounts for 29% of the gas emission globally, of which 58% contributed by cars and 23% by trucks. And therefore, all these issues call for modernization of transportation. And what I'm presenting here is aspiration to new technologies, not necessarily what is going on now, but what we can see for the future, what we want to have for the future. And this is an opportunity to use renewable energy to power new technologies for transportation. Okay, so what is required for modern technology is efficiency, comfort, affordability, and availabilities, while we want to solve the challenging problems of both energy and pollution, which impact, for example, public health and so on and so forth. Meanwhile, the current infrastructure can be still improved through computer technologies, including smart infrastructure, connected vehicle to improve the traffic, and mobility as a service, whereby with one application you can plan your trips and you can use multiple systems. For example, you would use a portable hybrid bike and then bus, and then again that small bike to reach your office easily. So, but the long-term solution that I see and would satisfy the sustainability in all aspects, energy, materials, and at the same time remove pollution, is something that would reduce the reliance on cars. But today we cannot not use our cars. It's impossible because the infrastructure does not allow that. So, but planning for new technology, appropriate technologies that is sustainable, clean, and so on, is probably the time to think about it seriously. And using mixed technologies to enable that the complementarity is also necessary. And if you want to use renewable energies, one of the schemes is to use direct directly that energy without transporting the energy, without using batteries. The direct use is the most efficient. And we don't have technologies for that now, so we need to think about it. Now, if you consider planes, how would we power planes in 30 years, 50 years from now, or 20 years from now? Fuel, is a problem. So I see that renewable energy generated hydrogen, not the way we generate hydrogen today, but solar energy generated hydrogen, for example, is the one way to go to power our planes. There is no other solution. You cannot carry a heavyweight batteries to run your electric plane. That's not going to work, particularly for these big planes. Maybe small plane for tourism or something like that, that's okay, but not to be used by American Airlines or any other company, or that's not possible. But hydrogen is the one that is really needed because it has high density of energy, how many joules per gallon you can provide, and it's clean. And you can generate it with solar, and the cycle is totally clean. You generate hydrogen from water, you burn it, and you get water, and again. So it's indefinitely, regenerable, and it's clean. And the tackling CO2 emission is also done, when using renewable energy. The proposed solution here is the integration of renewable energy with transportation. But what kind of infrastructure is suitable for such integration? Certainly not individual cars. You cannot fully power a car with solar energy. It is not possible. Not enough energy to power that mobile car. But if the transportation infrastructure is centralized, then you can centralize the powering, the energy source, and then you can use renewable energy, because electric trains, electric buses, metro, and so on can be easily powered with renewable energies. So the backbone of the transportation should be centralized, should be public transport, should be shared transportation. And again, the direct use, the complementary infrastructure, all of them are necessary to solve our current and crucial problem that we will see more and more trouble with the hydrocarbon and the pollution. And at the same time, we are going to improve public health, because not only remove the gas emission, but also you kind of help people moving a little bit. Okay, so these are pictures designed using one of the artificial intelligence, and you can see here some vision about how would be the future transportation, where you have wind energy, photovoltaic, the train is all of them powered with renewable energies. And all these are possible, but how to reach that point? You need to involve the users. You can, like, if you take the case of computers, how computers have evolved, from the Commodore or the Apple small computers to these very powerful computers, because they involved in a very clever way the users. They have a machine, they sell, they get money, they do more research, they improve, and so on and so forth. The same thing for transportation. You got to involve users, and to be able to do that, you need to attract them to use these shared and public transportation. And therefore, at the same time, to do that, these infrastructure must be dependable, practical, accessible, and must be attractive for the users. Probably I need to skip all these because I don't think that I have enough time. I can talk later about all these imagination, for example, different type of infrastructure there that could be powered by renewable energies. Having introduced this topic of integration of renewable energy to transport infrastructure, there is a question how to implement that, how to reach that point. Well, universities and research center can help doing that because they have expertise, they have R&D infrastructure, they can tailor the education programs so the students can be prepared to become innovative to do engineering projects and so on and so forth. Also, universities and research center can help shaping the transport policies for the future and can do real-world testing and validation work. They will help public awareness and engagement. As I said earlier, you really need to engage the public in order for you to succeed in developing these new technologies. And I think it's time to think about a certain organization that involves NC universities, research center, technical colleges, companies working energy and transport energy together to tackle a number of things that are urgent and to foster research in underexplored areas related to this emerging field. And the funding, I think the funding should be at least, there are two things. For the operation, you would think about some money to operate this organization. But when it comes to the research, I think the research groups need to fight to get their money. And if the vision is clear and the research program are there and call for proposal come, I'm sure they will compete and they will present the best solutions. So therefore, such organization now is really important, to promote this, this integration, the future technologies for transportation. At Elizabeth Cities, we have two types of activity and work. First one is solar energy research and education, and the second is engineering of drones. Both can be connected to what I was talking about, the new technologies that uses renewable energy. One of the projects is third generation solar cells, where we increase the efficiency of silicon solar cells using some advanced concepts. The second, which I really defend a lot, it's part of, it's one of the projects of the consortium that I'm leading. I'm really very favorable for this research, is the production of hydrogen using solar energy. That's great. We are working on that research and we are publishing a lot, but we're not at the engineering part of it. We are more on the science, the research, the understanding of what's happening, how we do better. But if a project like I was talking about comes in, so we can move to other phases, engineering, pilots, whatever. So, and we have another project which is the solar conversion of CO2 into alternative fuel, whereby we generate acetone, alcohol from CO2. That's great because you get rid of CO2 while you are generating fuel, new fuel that is usable. We have worked on powering UAVs and autonomous sensors, and we have a new project that is still starting, is the integration of photovoltaic with buildings. That is a very important thing to do because cities can generate its own electricity, can power the transportation infrastructure I'm talking about. So BIPV is great because it allows cities to power itself. The other area is engineering of drones. The ECSU School of Aviation and the Engineering Technology Department have been teaching drone technologies, design, fabrication, testing drones and so on. And they do have a complete program in aviation. My last slide here, I think I'm okay with that. There are three areas of research and development to tackle this new field of renewable energy integrated transportation. The first one is research on materials, devices, system, optimization of systems, and prototyping, testing, and performance analysis of some selected prototype, as well as collaboration with industry, for all these problems. The second field will be the setup of databases, whereby students and researchers will collect data, will organize it in a certain way that becomes accessible to engineers. So if one wants to find out the overall balance of a certain technologies, whether you have a positive energy balance or negative one, you need to have the data to do that. Because if you promote the technology, but in fact the total balance is negative, you are going, to nowhere. This technology will die one day. You can support it, you can have federal incentives, you can have all what you want, but at the end it will die because the balance is negative. So why don't we look at all the problem in totality, from mining the materials, to the fabrication, to the design, to everything, to the commercialization, to the spending of energy, the whole thing we studied. But there is no data to do that now. Having a database like that is very important for people who would use machine learning to study them. I think I'm done, and I used 15 minutes, I'm sorry. Okay, I'm done, and this is my contact for further discussion, and thank you very much.
Can I stand? Okay. Good afternoon, everyone.
Good afternoon.
Great. Oh, okay. So, as mentioned by the previous speakers, other campuses, a lot of cutting-edge technologies have been used. Very similarly, on UNC Charlotte campus, a lot of cutting-edge technologies have been used in many research projects. So today, I'm gonna give you, introduce one such research projects to you guys. The idea is to how to use deep learning for infrastructure performance monitoring. So with an emphasis on asphalt pavements. My collaborators, Wenwu Tang, Chris, and also those are our outstanding research assistants. So a little bit background, I think most of you already know. As Mayor mentioned earlier today, NCDOT manages the nation's second largest roadway network, which is probably most likely the state's most valuable asset. We're looking at about 6,000 lane miles of interstate, 20,000 lane miles of primary, and about 60,000 lane miles of secondary routes. So NCDOT engineers are responsible for determining when, where, and how to maintain roadway sections. So the impact of, as illustrated by this chart, the impacts of delayed treatments is quite significant. So it will cause more extensive and more expensive repairs. So for example, if you are looking at the picture on the right-hand side, for a timely treatment, maybe a chip seal would be sufficient, but if it is delayed, we probably will have to use this milling and resurfacing. More extensive, very expensive. So here, NCDOT has collected a large amount of data over the past several decades using two methods. For secondary routes, that's a windshield survey method. Usually it's time-consuming, labor-intensive, subjective in nature. And for interstate and primaries, automated survey method has been used, which can generate a lot video clips, still images, but however, the post-data processing is very long. Right now, the current time frame is about 6 to 8 months. So which means if I survey today, I'm gonna get the result. Right now it's May. plus 6 to 8 months by the end of this year. So our study aims to address some of the key issues. We introduced a cost-effective data collection method for secondary routes, and also we developed several advanced deep learning models to speed up the processing of collected performance data. So we're focusing on these two tasks. Number one, we did crack classification in order to determine what crack type it is. Task number two, we actually segmented those cracks, and then we can measure the length, the width, and also the area of those cracks in order to determine the severity level. Now, for crack classification, we use two methods. The first method is called rule-based approach, and as you can see, I think this is the pointer. Oh, okay. We are using bounding boxes, and we analyze the width and also the length of the bounding boxes. We look at the ratios. So for example, for this one, the length is much greater than its width, and that's a longitudinal. If it's other way around, we know that's a transverse. And if the ratio is close to 1, that's an alligator. No, but still, we misclassified some of the cracks, so that's why we introduced this deep learning-based approach using the most latest technology which is called vision transformer. And as you can see, the performance is consistently high. If you're looking at this epoch 80, you can see for different performance scores, they are exceeding 97%. Now, for the second task, we want to segment cracks. We developed a UNet model, and its architecture is shown right here. And again, the performance is quite satisfactory. It's greater than 96%. So here are some examples of a crack segmentation results. On the left-hand side, you can see those are the raw, original roadway surface images. And the images on the right-hand side with the black background, those are segmented images. So as you can see, it's quite accurate. This is kind of alligator crack. Those are predicted cracks. One thing I want to bring that to your attention is initially our deep learning models were struggled with small cracks in pavement markings. So if you can see, there are some markings right here. And actually the paint itself has some cracks. And the same thing here, you can see this is the lane marking, and that's a lane marking. You can see some small, horizontal, small, minor cracks. Our models thought, okay, those are the actual cracks. But after training the model with more labeled data, our model learned enough to exclude those markings from their predictions. Now, after images cracks are segmented, we use a methodology where the small bounding boxes, typically 2 pixels by 2 pixels, were allowed to travel, to walk on those segmented cracks. And as you can see here, the bounding boxes automatically adjust its sizes based on the geometry of the crack. So if the crack is wider, the bounding box will increase its size. If the geometry, the crack is actually narrower, the bounding box will just shrink to a small bounding box. So doing that way allows us to do a precise measurement of the length, width, and also the area of these cracks. Now, notice that those animations are shown in slow motion for clarity. And the actual image processing time is extremely short, as I am going to show you on the next slide. So, in summary, we conducted 2 deep learning tasks, image segmentation and image classification, to answer 3 key research questions. Question number 1, if we're looking at an image, is there a crack on this image? Question number 2, if there is a crack, what is the dimension of this image? And question number 3, what type of a crack it is? Now, deep learning models were trained on UNC Charlotte high performance cluster computers, and the training times are here, about 30.5 hours and less than half an hour, respectively. Now, those training times seems long, but once these models are deployed on a standard office machine, the actual image processing time is extremely short. So you can see averaging about 8 milliseconds, about 3 centiseconds. That's just a blink of an eye. In 2021, about 71,000 images were collected for Division 5. And as you can see, the overall image processing time is less than 1 hour. It's actually 0.8 hours. Now, assuming similar data volumes for the other 13 divisions, the combined total image processing time is about 10.5 hours. So we're talking about 2 days. Precision, again, accuracy is fairly high. Both are exceeding 95%. So as summarized, highlighted in previous slides, you can see that our approach can process a year worth of data in about 2 days, which is a significant improvement over the current time frame, which is 6 to 8 months, and also maintaining a very high precision. So what does that mean for NCDOT? That means our approach can help NCDOT engineer to do accurate and a timely performance assessment and then make informed decisions. So in other words, for roadway sections that need timely treatment will receive those treatment on time without delays. So that's significant. Why? Because if we're looking at the talk about safety, by doing that, the roadway will get treated on a timely basis, potholes will be fixed, and the traveling public can drive on safe, fixed roadway sections, and also we reduce the number of repairs, so people don't have to drive, don't have to be rerouted to drive on unfamiliar roadway sections. So that's about safety. Durability, again, if roadway has been fixed on time, we don't have to wait and until the condition got further deteriorated. So we're talking about a reduction in the overall maintenance cost over the life cycle of a roadway sections. And again, talking about efficient, we are reducing the overall levels carbon emissions of this roadway section. So we're talking about the sustainability of our nation's second largest roadway network. So again, I want to thank NCDOT for supporting this research project, and also I want to thank the following NCDOT individuals who serve on the research project, steering, and the implementation committees. With that, I conclude my presentation, and I'm going to hand that over to Dr. Hildreth.
Trade spots here. Thank you, Megan. Thanks, Christy. Thanks, you guys, for being here. I was asked to speak on 2 things today, so I'm going to give you a very, very high-level overview of a project that we've recently completed with the North Carolina Department of Transportation, and then I was also asked to give some thoughts on why, or the value of the research partnerships to the university, right? So these partnerships that we've been talking about. So a couple of pieces to this. So the project I'm going to speak on is we recently completed a project to evaluate the feasibility of electrifying ferry vessels in North Carolina. So the ferry system, part of the North Carolina Department of Transportation, and this is usually the point where somebody screams out, "You mean like batteries?" Yeah, batteries, right? So electric power for vessels that look like that. So high level, this is what we looked at. When you're looking at vessel electrification, this is what you're looking at. The far left-hand side, the gray, is your traditional diesel mechanical. You're burning diesel, you're producing mechanical power to propel the vessel. The colors didn't come out very good, but the next 2 are supposed to be blue. You're still using diesel as your primary source of power, but you're using that diesel to produce electricity that then propels the vessel. So onboard generation of electricity originally from diesel. And then the last three, which are green, sort of, sorry for the colors, is where we replace the diesel with some alternative fuel, electricity, so it's electric power, electric drive, and then the question becomes, do you have onboard batteries, onboard storage or not, or I'm sorry, onboard generation or not? Do you have a backup generator? Or do you strictly just have batteries that get charged when you plug in? Or ultimately, the far right-hand side is where we're using something other than the grid to get the electricity. We're producing it with a fuel cell on board. But that's sort of the spectrum of electrification options. I can tell you that all the vessels right now are diesel mechanical, so that was our baseline. We chose the diesel electric with peak shaving, so a hybrid with a little bit of storage on board that does not plug into the grid as one option. And then that plug-in hybrid where we do have onboard generation as a backup mechanism, but the primary source of power is the grid, and we charge the vessels when they come ashore. And so those were our three options that we looked at. I'll give you one set of results. So we looked at 4 different locations, and this is one of them. So what we had to do was first figure out what it was going to take. And so what it takes to power a vessel is that this blue piece right here, right? To charge this vessel, and that vessel would have 1.7 megawatt hours of batteries on board. And I should know, but that's got to be like 1.5 million cell phone batteries or something. I don't know, right? It's a lot of batteries. So it's got a big set of batteries on board. And we have to charge that at about 4.7 megawatts, which is a lot of energy, a lot of power, right? And so that's what we have to put into the boat. Now we can pull that directly out of the grid, or the better option is to set a bank of batteries on the shore, pretty good size amount of batteries, and sort of slow charge that, right? So for 37 minutes we charge these batteries, and then for 8 minutes we pull the energy out of these into the vessel, right? So that's sort of the scheme of how these things work. So what's the big deal? Well, the big deal is that over the life cycle of that vessel, which is about 40 years, it's significantly cheaper to run a plug-in hybrid electric vessel than it is a diesel mechanical vessel. Okay. Now the magnitude of these numbers change a bit depending upon location, because of the amount of energy that's used and the amount of hours the vessel operates on a daily basis and that sort of thing. But in general, I mean, you can see right here, you're talking about almost a $10 million savings over the lifetime of that vessel, which is substantial, right? 10 million on 70s, about 14%. Now, what you end up doing, though, if you look a little bit closer, is these tan collars down here are sort of your capital costs. This is what you got to buy up front. So you're going to spend a whole lot more, right? It's about $30 million to go buy a diesel mechanical vessel. It's about 45 to go buy a plug-in hybrid. So your upfront cost goes up. But what you trade off is this blue stuff, which is your operating cost. And this piece right here is just diesel fuel over the life of that vessel. Right, so that goes to almost nothing. Remember, we have some backup generators on here, and so we figured they had to run some, right? And you've got to buy some electricity. But this blue is your operating cost. So what you're really doing is you're trading a whole bunch of operating cost for less capital costs. And overall, you come out on the good side, right? And I included this one in particular because sometimes, and they don't all look like this, you know, the plug-in hybrid without that shoreside battery is the worst case scenario. Right, because I said if we don't put that in there, then we've got to pull all of this power right out of the grid. You pay a ton of money for that. And how much you pay depends on how much you want, where you get it. Prices vary across the state. And so I just thought this was interesting that the plug-in hybrid without shoreside batteries was more expensive over the life of that vessel. They don't all look like this, but this is sort of indicative of what we looked at. So what? So there's substantial economic benefits to this, right? So going to electrification, what we learned is that not all locations are equal, and it's not just the economics, right? It all ultimately comes out in the economics, but we're talking about the amount of energy that's necessary, the schedule the vessel runs on, the grid, what it's capable of, what kind of improvements are required to get you what you need. You have to look at the specifics of the location. And the other thing, because those are all different, you end up with really a possibility of different vessels at every location, but that doesn't make a lot of operational sense. So what we recommended is that you understand the specifics of each location, but that you plan for this fleet standardization, right? So you do a design mashup of all your locations so that a vessel isn't tied to a specific location, right? It can be moved to different places around the state as needed. And another thing that we came up with that was very important is this partnership with your local utility. Right? Your utility it's your primary source of power, to say it bluntly. And a partnership with them over the next 40 years is going to be extremely helpful. And they can be extremely helpful up front if you work with them. And we had some folks that were just, there's one group that's already going out and getting grants to improve their grid, hoping that this thing comes one day. They were very interested in it. So that partnership early on is extremely, extremely valuable. And so that's our very high level of what we did, the kind of work that we did with the department. I did with the Department of Transportation. I had a team working with me over the year, and that was the most recent we've done over the years. So to switch gears a bit, what is the value to the university of a partnership with the Department of Transportation? And I sat back and I thought for a while, and I've come up with 4 things. I think that the value to the university is the accessibility of the research funds. Right, so there's lots of places. I work in the research office at Western Carolina, and there's lots of places that folks can go get money. The DOT is one of those, and I think it's a valuable one because it is accessible to us, and it's competitive, which is important because that demonstrates value to the university of the researcher's work, but it's accessible, right? I don't know what my success rate is with DOT over the years. It's not uncommon for some of these large federal programs to have a 3% success rate. So you submit a proposal, there's a 3% chance you're going to get funded. DOT is a lot better than that for a couple of different reasons. They're a different type of program, and we'll talk about that here in a bit. But it is very much accessible to the faculty. It covers a broad range of topics. I alone have done work with the maintenance fleet. Don and I have done some of this work on he's done the work on the pavement stuff. I sort of helped a little bit. But we worked with the maintenance folks. We've done pavements. We've done fleet stuff. We've done ferry stuff. There's environmental work. There's policy work. There's all kinds of different topics, a range of topics, and that's valuable because it's not this little specific thing, right? And you get to connect with the NCDOT champions. So Kat's in the room. I work with her closely on this project. She's with the ferry system, but I get to connect with that champion at NCDOT, whoever it is, right? You don't always get that at other funding programs, okay? So the ability to connect with the real people in the real world is important. It's flexible. The DOT has been wonderfully flexible over the years. They understand that we work on an academic schedule that's different than the most of the world. We have to fit our work inside our academic environment. We're working with grad students, and they have requirements. They've been very good to work with us to fit in our world, and we try to fit into their world as best we can. They also it's flexible in that they support the scholarship of discovery. And so that's what we've seen a lot of this stuff, right? People are learning new knowledge, and that's valuable and that's extremely important. But there's another piece that is the scholarship of application. So that is, we know something, now that's applied in the real world and learn more about it in that environment. And DOT does both of those, and that's kind of novel and very, very valuable to the university. The other piece that we get out of it is I've seen a lot of folks over the years develop a lot of research capacity. And so if you think about a young faculty that comes in, they're new, they're trying to figure this thing out, and they've got to get some stuff going. And so I've seen a lot of faculty that have been able to work with DOT on projects that are beneficial to both. They get gear, they build their labs up, right? They start to develop an expertise. And so they're developing their capacity, and they're really kickstarting a research agenda. So it's, you know, they've got these ideas, and DOT is a place to really get started. And the next thing you know, they're working at the federal level and other DOTs, and they've really got things started. But it started because NCDOT or some other, wherever they are, right, worked with them to help them kickstart that research agenda. And then the last reason I think that these are so valuable to the universities is because they are long-term relationships. Right? I came to North Carolina 15, 16 years ago. How long have we been here, Don? 15, 16 years. It's been a while. Don and I started at Charlotte together. And we started working with DOT right away, and we've continued to do so, right? Different areas, but it's been a long-term relationship. It's one that we, you know, they come to me, and I go to them, and we work together. And it really is this partnership in research and development. It's, you know, we're helping each other, we're reaching out to each other. And it really gives the faculty an opportunity to expand what they do, explore new areas, and support their region, their state, the community in which they work. And so that's the 4 reasons I think that these partnerships that we've talked about today are so beneficial to the university themselves. And with that, I'm going to turn it back to Christy for whatever's next. Thanks.
It was wonderful to hear about all of the research projects that are going on at the different universities across the state, from the mountains to the coast, right? So I do have a question, some questions for you all. So how can the outcomes of state government-funded research and development projects be effectively communicated to the public to demonstrate their value and impact? And this is for everyone.
Well, I'll start. I have some rest. I think you. I would say public outreach, probably the number 1, right? As a academia institute or as researchers, we often do our research in the lab, in the field, whatever it is, there's this sort of confined, developed process. But eventually, the important thing is, how do you interpret? How do you bring the result to public, to the appropriate entities? I often told my PhD student, doesn't matter how complicated a model you run, as we heard, you know, Dr. Chen doing all the big data analysis, it doesn't mean anything. It doesn't do anybody any good unless you can interpret, unless the public can understand what the result is. So I think oftentimes we do the research, but another important step is really disseminate and reach out to whoever needs the results.
I think the impact is important, right? And it's the ultimate impact, right? So what Dr. Chen does is amazingly impressive, but what's more important from a public perspective is the so what that he got to at the end. So what does that mean? That means better roads, cheaper roads, right? That's what I think that's what the public needs to hear. And the other piece, so I would say focus on the impact and let the professionals tell the story. We're professionals in what we do. We are not professional communicators and storytellers. So we can talk really well amongst each other to academics, and we have this tendency to use these fancy words. But we need to let the professional communicators tell the story in a professional way. And I know that DOT recently had a call out for some communication video kind of thing, right? That was looking at getting professional communicators to tell the story as opposed to the engineer or whatever that did the work, right? We're good at doing the work. We're not good at telling the story.
So I want to add something to that. So keep implementation in mind because eventually NCDOT will apply our results if the result is good. So my experience tells me that from time to time, NCDOT engineers are very open to discussions not necessarily at the end of the project, but during the project, we have weekly, quarterly meetings just to fine-tune the direction of our research to make sure it is useful eventually. So I think that's important too.
I think the students that, who we are educating can be our ambassador to the public because they will learn, they become involved, they get excited, and they really can relay the message from the classroom, the lab, the training to the public. I have asked the group of students to develop a video for about what I have presented, and they did a really good job. And I intend to continue that work with probably, improvement. This kind of media can be used, in news channels or whatever, or television to educate the public. Students probably are better storytellers than we do, scientists and engineers. Our work is generally focused on publishing papers, creating patents, things like that. But to reach out to the public, I believe it needs to be done at different levels, outreach. We can go to schools, we can give presentations and so on and so forth, but also involving students can be something impactful.
All great points from outreach and having that impact and using the students to help spread the word as well. So how can collaboration between state governments and academic institutions enhance the quality and effectiveness of research and development projects?
I think our experience proves it's extremely important. What I see is a mutual relationship. As you can see, when we start the research approach or project, here I would applaud, NCDOT worked with quite a few DOTs. I think NCDOT has this very embedded process before they let out any research grant, particularly for universities. They actually have this research idea submission process, which means, well, if faculty want to do something. And the second stage, they actually match a professor or a group. If you submit this idea, they actually reach out or select some champions from NCDOT, which means really before the RFP come out, they already connect. If your idea, doesn't matter how marvelous it sounds, if it doesn't have NCDOT support or champion, most likely your idea will not get selected. So even at the pre-proposal stage, they already consider who is going to be the client, who will be using it. With that, once the project selected and awarded, or when you carry out the research, what I see the mutual benefit is for the research. For us, when we do this, we'll have this ultimate sort of goal in mind. We're going to help DOT improve efficiency, effectiveness. Doesn't matter what subject is. And same time, of course, I think John mentioned a great deal of the research, what it will do to benefit the university or researchers, certainly help us to nurture, train, educate our students, and also strengthen our research capabilities. Of course, with multiple projects, multiple years, we certainly develop this longevity, sort of you carry out or enhance your research capabilities.
So I agree with what Dr. Liu mentioned. I think the mutual communication is very important. At the beginning, NCDOT has a research idea screening process, and we need to talk to it. We need to find somebody who agree upon our ideas, and then is willing to sponsor our research ideas. And along the way, the steering committee just keep giving us feedback based on our quarterly reports and tell us, hey, this is not exactly what we're trying to achieve. Can you make those changes? And that will direct the direction or usability of our final deliverable. And meanwhile, as researchers, we should also communicate the potentials of those high advanced technologies, because sometimes we can use this model to do some things, but along the way, we can do some additional stuff without spending too much time. So that's kind of a byproduct of our research project. So I agree with what Dr. Liu mentioned.
I think cooperation, university, industry is very important in that aspect. Because we as a researcher, if we don't have a buyer, if we don't have a customer, somebody who is going to use my research, then I'm not motivated. But if I know that at the end of the road, there's somebody is going to take my results, I'm more encouraged, I'm more focused, and I'm sure that my results will be better. So joint works with industry are very important. And I think NC DOT can kind of facilitate these kind of things, creating some connections. I mean, encouraging this type of work, and let both work together and improve each other. Both sides. I mean, industry, what it wants, it goes to the researcher, and the researcher adjusts his knowledge, his research, his focus, and provide products. I think this is a good way to reach the goal. Okay.
Are there any questions from the audience? Yes.
More protect the pavement valuation. Some of the other issues are like cross slope, as far as what's leading to rutting or flat areas. Is the system having method to evaluate that as well, or GoPro? I know that would be some type of radar, I guess you would need. I don't know if GoPro could do that, but is there some way to look at that as well?
That's a real good question. So far, we're looking at 2D images. Based on those 2D images, we're able to identify transverse, longitudinal, and alligator cracks. You had mentioned about some different types of stresses, for example, rotting. Now we're looking at the depths, or how deep the rotting is. So that involves 3D images. We're not get to that part yet, but we're hoping that we can get to the phase 2 of this project, so we are able to process 3D images. Because I know that NCDOT has been collecting both 2D and 3D images or video clips. So images are there. It's just how we process those images. Very good question.
Oh, yeah, go ahead.
The other, I live in a rural area, so farming is a big thing, and I know y'all talk about alternate ferry. I live in Western Carolina, talks about the ferry. Yeah, my family farms quite a large acreage, and is there technology, anything for powering tractors or alternative fuel? I'm just wondering, in 30, 40, 50 years,
So yeah, no, you're right on the. So it's not that the ferries are parked in one place overnight that it makes it feasible. It's the fact that they run a short and defined route on a very predictable schedule. So I mean, I left it out for time, but we looked at the 4 shortest routes, river crossings that ferries operate on, right? So we can't. I say we can't. It would be very difficult to electrify the route to the Outer Banks, right? For a couple of reasons. One, it's a long run, particularly if we're going, that long run that goes from Cedar Cliff's where I live. Sorry, but that's a very long run, right? For a couple hour duration, and there's very little power available on the Outer Banks. So even if we could charge the thing up when we got there, it'd be dead, right? So it's this idea that it makes a very short 20, 30, 40-minute crossing and comes back to the same spot all the time. And so you talk about agriculture, think of a snowplow, right? That's the one that everybody goes to is, well, what are we going to do with these electric trucks? We can't plow snow because we can't stop, right? We stop long enough to fuel the thing up, maybe get a cup of coffee, and we shove the guy back out on the road. And they run pretty much 24 hours a day. And how are we going to do that? Electrics. No, I get it. But it's the same thing, right? But electric's not the answer, right? Because it doesn't meet the use pattern that electric serves. So other fuels. So there's a couple of things that are being looked at. There's this thing called renewable diesel. If you're familiar with renewable diesel, very high level. It's produced from waste oils, particularly fish oils. It's got a higher cetane rating. Think octane for diesel, cetane rating, and it's got reduced emissions products. So it's a little better fuel, and it's a little cleaner fuel. And so that's available now. My understanding is, and that's run a lot on the West Coast, right? So if you're in California, Oregon, Washington, you're not really running diesel fuel, you're running renewable diesel. And they're subsidizing that heavily to make it economically competitive. But my understanding is it's very difficult to get that right now. It's available on the West Coast, but really on the East Coast, not so much. I think COVID really impacted the production of that. There was a whole lot of capacity being developed right as the pandemic hit, and I think that didn't get realized. But so there's renewable diesel, and then there's some folks are burning straight hydrogen in a diesel engine. That's an option, and then another option for electrification would be the fuel cell, which really takes hydrogen and then produces electricity. Right, you're not storing it and you're producing it as you need it. Yeah, kind of, right? But my understanding is there's some folks right now that are producing hydrogen fuel cell. I mean, they're running them out west on test purposes. Class 8 over-the-road trucks. Volvo's done a lot of work here. The guy from Volvo, right before lunch, they've done a lot of work in this area. But my understanding is the fuel cell is probably a few years away from really being viable, large scale. But those are kind of the fuels that are being looked at.
How about wind energy?
I'm sorry?
Wind energy.
Wind energy. I guess if on a tractor. Oh yeah. Well, I mean, yeah. So So any renewable energy, right? It doesn't. How the energy gets into the grid. I don't want to say it doesn't matter, but if you're charging your battery, it doesn't matter where it comes from, right? As long as the electricity's there, and so it can be nuclear, renewable, solar, wind, right? Whatever we've got.
Another question?
Yeah, just related to fairly static reproductive. Is the report of the project publicly available? That's one question. And
Yeah.
the second question, I've seen that you were focused on electric ferries with or without ability to charge them.
So two parts to that, and this is really a benefit to kind of fits what we've been talking about. The benefit of working with DOT. All of these research projects, the final reports are available publicly. If you Google NCDOT Research Unit, it's not the easiest thing, but you can. There's some search. You can find all of the final reports on all this stuff. If you really want to know, just catch me later, and I'll shoot you an email. The other piece was hybrid. Yeah. So what we looked at was, in fact, all of the vessels, diesel mechanical is our baseline. All the electrification options were hybrids, right? So we had some not long. It didn't take long to come to the right answer, to be honest. We looked at it and said, we must have, is a better way to say that, we must have a generator on board, right? For two reasons, or at least two reasons. Number one is these things operate in a hurricane-prone area. What happens if the hurricane comes through and the grid's down, right? They can't not operate. They're critical transportation infrastructure, and so they have to be operational. And so we had to have the ability to pump diesel into them and go to work, right? The second reason is because the ferry system operates their own dry dock at Mans Harbor. And so, you know, if you're building and designing this ferry to hold enough energy to cross the river 30 minutes, you know, a 3/4 of a day trip up from Southport to Mans Harbor is not an option, right? And so we had to have it for range extension as well, because they have to be able to move around. And so everything we looked at had an onboard generator. Now the question is, how much is it used? Is it used only as a backup when needed? Or is it used all the time, sort of the diesel locomotive model, to where you're burning diesel and you're producing electricity? And the idea there is, if you can go back one slide. Oh, I have the clicker. Oh, sorry. I got you, right? So that diesel electric, there's two diesel electrics. You're burning diesel all the time and you're producing electricity, right? But the idea is that you can operate those engines, those internal combustion engines, at a more efficient duty point, right? And so you increase the efficiency of that diesel engine in that model. Now, what's interesting, and I had this conversation with a fellow yesterday out in the Pacific Northwest, those, in my opinion, are actually the worst. And the reason is you get the worst of both. You've got to you got the capital cost of purchasing a electric propulsion system for your vessel, more costly, and you've got to buy diesel for the next 40 years to run them, right? Your high operational costs. So from my perspective, the diesel electric is sort of the worst case scenario.
Yes, I agree that it's going to be very expensive, probably the most expensive solution. But you can actually have ability to move, to not use diesel in harbors and ports.
Mm-hmm.
Kind of move it from berth and start using diesel when you're open sea.
That's a possibility. Yeah, particularly if you have that a little bit of storage on board, right? So you can run electric to get so far out and then turn. Yeah, absolutely, that's a possibility.
Are you planning to try hydrogen? At least for the feasibility, whatever source of hydrogen later, that's a different story.
Yeah.
But,
We started this 2.5 years ago, something like that. At that time, we looked at hydrogen and we made the decision early on, so a couple of years ago, to not include hydrogen in this study. We didn't feel that the technology at that time was ready. I mean, it's clearly coming. There are some folks. I want to say there's somebody in the Bay Area, right, that's running a hydrogen-powered ferry right now, or getting ready to.
what kind of technology? Is it fuel cell?
I think it's a fuel cell.
Diesel run by
No, I think it's a fuel cell. I think, but my understanding is that those are a ways away, right? So we think of electricity as being new. The Scandinavians have been doing this since 2008. They've had electric ferries since 2008, and they are far ahead of us. I had a call with some folks not long ago. So we're talking about, right, our biggest charging capacity was like 4.7 megawatts. Washington State is doing this right now, and they run big vessels, and we're talking about 15 megawatts of charging, so 3 times what we're talking about here. And the Norwegians, they wouldn't tell me, I'm sorry, I shouldn't say the Norwegians. They're Scandinavians. I don't know that it's Norway in particular, because they wouldn't actually tell me the location. But they're talking about 90 megawatts of charging. It's like 20 times bigger than what we're doing here, right? So we think of this as new, and it is new. There's not a lot of this in the U.S., not a lot of this in North America, but there's pockets of it popping up. But this is really not new technology. This has been around for 15 years.
How about photovoltaic?
PV doesn't generate enough energy.
Well, you can have extended area for powering, for charging the battery.
Well, I thought you meant on the vessel itself.
Oh, not on the vessel.
Yeah, so I think PV is an option if you have enough, if you're in the right location and you have enough area, right? So you could build a solar farm adjacent to the terminal and maybe produce enough electricity. Their wind would be an option, right? So you could do renewables, sort of localized generation, and then storage would be an option. Yeah, that's actually sort of a phase 2 we've been talking about, is to see if do the analysis to see if that's feasible.
Thank you so much to our panelists for being here. I know that as educators, you often do not receive the gratitude that you deserve. And I personally want to thank you for your relationship with the department and for being here today. I know that y'all are busy, and for your commitment and passion for what you do for the future of North Carolina and for transportation. So thank you so much for being here.